last lesson of chapter 1. So what we're going to learn about, again, all stuff that we touched on with our water project. We talked about this, and now here it is on the interwebs for you. All right, we've also talked about the medium being the midpoint. Anyhow, we're going to cover a lot of things that we've already covered in this lesson. We'll just get into them a little more deeply. We understand how to calculate a mean. It is exactly the same as an average, right? Our median, however, because we have an even number of data values, we're going to have to take an average. We talked about how to calculate the quartiles and the IQR. So you have all of these things probably written in your notes already. If you need to take a moment to look at this, pause the video, write this stuff down if you don't know this stuff. And here's an illustration of how to calculate your interquartile range and a really nice interpretation of the interquartile range, right? If our data set is being split up into quarters, right? It would make perfect sense that there would be 50% of our data in between quartile 1 and quartile 3. We talked about our 1.5 IQR rule for outliers as well. Go ahead and take a look at this if you didn't get it the first time or if you need a refresher. Other than that, we'll move on. We talked about the 5-number summary. Here it is. We're going to use that 5-number summary to make a box plot. Most of you have already made a box plot before. Okay, where does this stuff come from? Right here. Right here. There's our minimum. That minimum is not 10. I drew the arrow from the wrong spot. Our new minimum should be 5, right? Okay. So here we go. There's our min. What's going on here? It looks like our first quartile is 15. All right, so this guy here, Q1. What's this? Our median. Here's our median. Remember, we calculated our median by doing 20 plus 25 divided by 2. Over here, quartile 3. We calculated quartile 3 in the same way, right? And then we have our max over here. And if you were to multiply 1.5 times the IQR, you would find that 85 is above 1.5 times our interquartile range, which makes it an outlier. So in this case, we're talking about each deviation, right? It turns out that our mean in this case is 5. So our mean, our x bar, is equal to 5. And then we're just showing how to calculate each deviation, right? Remember, our standard deviation is the average difference each data point is from the mean, roughly. We have a calculation of standard deviation occurring right here for our number of pets. Right, and when we take our this actually is this 2 should be up in our superscript, right? And so each of these are supposed to be a superscript, right? An exponent. So we're not doing 3 times 2, clearly, right? We're not doing 3 times 2, we're doing 3 times 3, right? We're doing 3 squared. If we sum all those up, I believe that turns out to be 52, which is where this number comes from. And we're going to divide that by n minus 1, which is our, right, n is our number of observations. So n is our number of observations, or data points. And that's right there, right? This is n minus 1. So there's n. And we're calculating our standard deviation. So that first number is the variance. Remember, our standard deviation is the square root of the variance. Okay. And there is the long way of writing that, right? The official formula, official if you will, but the precise formula. All right, we're going to choose measures of center and spread. Remember, I've talked about what happens to median and mean for skewed data, right? For skewed data, we're going to want to use median instead of mean as a measure of center. And IQR is going to be a better measure of spread, right, for our skew distribution. All right, and this is how we're going to organize an answer to a statistical problem, right? We're going to state the question that we're trying to answer. We're going to come up with a plan. We're going to make graphs and carry out calculations, and then we're going to conclude. And always, okay? Always remember, your socks. All right, when you give your conclusion, you need to give it in the setting of the real problem and talk about the distribution in terms of socks. And that is what we learned today. Thank you so much for watching.